Hello and welcome to this knowledge clip in which I will discuss with you a certain part of our gamma camera detector, and that is the collimator. You have a radioactive patient here, radiation coming from the patient and going towards the camera detector, and it first encounters the collimator. After that, it goes through the crystal, produces tiny flashes of light, will be registered by the photomultiply tubes, and a computer will make an image out of it. But today the collimator. We look at a parallel hole collimator, and it looks like this. We have small partitions, and these are lead walls, and these lead walls have a certain length, a certain thickness, and a certain distance in between the walls. And these lead walls we call septa. So we have a radioactive source and we have radiation coming from it, the two arrows in this picture, and one arrow reaches the detector and the other angle does not, the other arrow does not. And this is what the collimator does. It filters the radiation that comes into the system from a certain angle, and we don't want that radiation coming in an angle to be registered because it does not contribute to our image. We only want the radiation coming straight into the system. Now, there is a relationship between resolution, sensitivity, and the number of septa. Here we have a radioactive source again, and we have radiation coming from it. We have our crystal, and we have our collimator. And here you see 14 septa, so the number of septa means that in the end, some radiation will go through the collimator and some radiation, most radiation in this case, will be absorbed by the lead walls. Now, if we halve the number of septa, you see that more radiation can pass through the collimator. So this arrow reaches the crystal, and on the right side, an arrow reaches the crystal, and the rest is still being absorbed. Now, is this a good thing or a bad thing? For the resolution of your final image, this is not a good thing because you see a very tiny dot of activity will be translated in your picture as a larger area, a larger dot of activity. So this means that your resolution of your image will go down. However, your sensitivity will go up because more radiation can pass through the collimator and will contribute to your image. So you have an image in a quicker way. However, it will have a poorer resolution. So using less septa means a higher sensitivity and a lower resolution of your system. Now let's look at the length of the septa, and pretty much the same goes for the length of the septa. Here we have quite long septa. We have some radiation that will go through the collimator and will be registered by the crystal, and we have some radiation that will be absorbed. Now, if we shorten the septa, as you can see, statistically more radiation will go through the collimator and will reach the crystal and will be registered by the system. So this means again that the tiny dot of activity will be translated in this case as a larger area of activity. And this is not good for your resolution, but it makes your system a lot more sensitive. More radiation will go through the collimator. So your sensitivity, if you use shorter septa, will go up, but your resolution of your final image will go down. And now you can choose your collimator. There's just one more thing you need to take into account, and that is the energy of the nuclide. And the energy of the nuclide means a certain thickness of your septa. We have lower energy, medium energy, we have high energy nuclides, and you need to choose a high energy collimator in case of a high energy nuclide and a low energy collimator in case of a low energy nuclide. Because a lower energy nuclide will send out radiation with a lower energy, and in case of the high energy nuclide, the high energy might go through the walls of the low energy collimator. So therefore, if you use a high energy nuclei, you need to choose a high energy collimator with thick septa. And then we can determine if we want a high sensitivity collimator or a high resolution collimator, for instance. And these have certain characteristics, namely the space between and the length of the septa. So a high sensitivity collimator means that your septa will be very short and the space in between the septa will be very large. If you have a high resolution collimator, the length of the septa will be very long and the space in between the septa will be very tiny. And you can combine those letters and you get a low energy all-purpose collimator, a low energy high resolution collimator, low energy high sensitivity, etc.